In today's lesson, we will be positioning and labeling triangles for use in coordinate proofs and writing coordinate proofs. We have some vocabulary to look at. First, what is a coordinate proof? And a coordinate proof is using algebra to prove the geometric concept, and we do it on the geometric plane. In order to do this, we have to remember some formulas way back from Chapter 1 and Chapter 2. The first formula we need to remember is the distance formula, because if we're trying to prove that a triangle is isosceles, we have to be able to figure out how long the legs are. The distance formula, remember the trip to the mall, is the square root of the quantity of x1 minus x2 squared plus the quantity of y1 minus y2 squared. If we want to prove that two sides are parallel or that we have a right angle, we need to find the slopes of the sides. To find the slopes, we need the slope formula. M equals the quantity of y1 minus y2 divided by the quantity of x1 minus x2. And sometimes we will also be required to use the midpoint formula in order to find a point on our coordinate plane. And this is an oldie but goodie. To find the midpoint, you add and average the endpoints. So you do the quantity of x1 plus x2 divided by 2. That gives us the x value of the midpoint. And y1 plus y2 divided by 2, which gives us the y value of the midpoint. Before we can actually do any type of a coordinate proof, you have to be able to position the figure on the coordinate plane. There are some hints to make it easier to work with. One, take advantage of the origin. Its ordered pair is 0, 0. That's going to make it easier for distance formula, midpoint formula, or slope formula. It's easiest to use it either as a vertex or as the midpoint of one of the sides. The second thing that makes coordinate proofs easier is if you put at least one side of the figure on an axis. Sometimes you can even get two sides if there's a right angle involved. The third thing is to try to keep the figure in the first quadrant. And fourth, choose coordinates, because we're actually choosing them. We're not going to be using numbers. We're going to be using variables. Choose coordinates that make the use of the formulas as easy as they possibly can be. The first thing we need to be able to do is position a triangle on the plane. So I've chosen an isosceles triangle. The length of the base is 2a, and the length of the height from the bottom of the isosceles triangle to the top vertex, or the vertex angle, has length b. What I'm going to do is I'm going to use the first technique, which is to place the vertex on the origin. Now, if the vertex is on the origin, the ordered pair of that vertex is going to be 0, 0. Since the length of this base of the isosceles triangle is 2 times a, the coordinate of the other end of the base is 2a, comma, 0. Now I need to find the coordinate of the vertex, and that is going to be, remember, the vertex of the isosceles triangle is going to be halfway across. So if all the way across the triangle is 2a, then halfway across the triangle is going to be 1a. So it went over a units on the x-axis, and it went up b units on the y-axis. So the ordered pair for the vertex of that particular triangle would be a comma b. Now, if it's an isosceles triangle, sometimes it's nice to put the vertex on the origin. Other times it's nice to put the vertex on the y-axis. So here's the other technique. I would take my same triangle and I would line it up so that my vertex is on the y-axis and my base is on the x-axis. If I do this, the ordered pair for my vertex is going to be 0, comma, b. Went over 0, up b units. Since the base is 2a, the ordered pair on the right end is going to be 1a, comma, 0, and the ordered pair on the left end is going to be negative 1a, comma 0. Now I'd like you to try and put right triangle XYZ with leg XZ being d units long on the coordinate plane. First thing is you are going to need a right triangle. So let's get a right triangle here. And one side of the right triangle is going to be d units long. Try it and then check your answer. The first thing is, since this is leg XZ is d units long, my bottom ordered pair needed to be x and z. So x I'm going to put at the origin, and I'm going to slide my triangle over. I can draw it however long I want. Z is going to be at the far end, and that is going to be d units long. Since it's d units long, first our ordered pair at the origin is 0, 0. So I know the coordinates of x are 0, 0. The coordinates of z are going to be d comma 0 because I went d units to the right and 0 up. The coordinates of the vertex at the top are going to be 0 comma anything you choose. You can choose your own variable. I think I'm going to use m for mathematics. So I chose 0, m. And those would be the ordered pairs for my right triangle. The next thing we're going to work on is finding missing coordinates. In this circumstance, they're actually going to give us a triangle to start with, and they're going to give us some of the coordinates. And our job is going to figure out the remaining coordinates. First off, I know that E is at 0a, which means the length of this side of my triangle is a units. I know where F is. F is at 0, 0. That's the easy one. Now I need to figure out how to label G. If it were just any old triangle, I could pick a variable for my x value, but this happens to be an isosceles right triangle, which means the two legs have to be exactly the same length. So if from F to E is a units, then from F to G is also a units. That meant I traveled a units to the right, so my x coordinate is a, and 0 units up, so my y coordinate is 0. Now I'd like you to try the next problem, finding the missing coordinates on the triangle that's shown. Pause the video, try the problem, then restart. The correct answer is 0, 0, 1/2 A, B, and A, 0. If you got this incorrect, raise your hand and I will come help you. To actually write a coordinate proof, you have to have a figure on the coordinate plane and you have to have some additional information. In this particular problem, we've been given an isosceles triangle, which is triangle AEC is isosceles. We've been given the figure on the coordinate plane, and we've also been told that B, D, and F are the midpoints of their segments. And our job is to prove that BDF is isosceles. Now let's plan that out first. We're trying to prove triangle BDF is isosceles. This means that two of our legs need to be the same length. That means I need the distance formula to get two legs the same length. Now the other problem is I don't know where B, F, and D are, but I do know that they are midpoints. So to figure out exactly where they are, I'm going to use the midpoint formula on segment AE, segment AC, and segment EC to determine exactly where the midpoints are. So let's start with point D. Using our midpoint formula, first for segment, let me take a look at the figure. Let's do segment EC first. The endpoints are E, which are negative 2a, 0, and C, which are 2a and 0. We're trying to find point D, which I could actually see on the graph was at 0, 0, but let's show how you get it. I would do negative 2a plus 2a divided by 2, and 0 plus 0 divided by 2. That gives me 0 over 2 and 0 over 2, and 0 divided by anything is 0. Therefore, point D happened to be at 0, 0. The next point we're going to shoot for is point F, which is the midpoint of segment AE. So I need the coordinates for A and the coordinates for E. A happens to be at 0 and 2b. E happens to still be at negative 2a and 0. So doing the midpoint formula, 0 plus negative 2a over 2 and 2b plus 0 over 2 is going to give me negative 2a over 2 and 2b over 2. Simplifying these fractions gives me negative a and b. Therefore, the coordinates of the midpoint of this side are negative a and b. Now I need to find the coordinates of the midpoint of segment AC, and that's going to be point B. The ordered pairs for segment AC are A is at 0, 2b, and C is at 2a and 0, following the same formula. 0 plus 2a over 2, 2b plus 0 over 2 gives me 2a over 2 and 2b over 2. So therefore, the midpoint of segment AC is A, comma, B. All I've done so far is actually find the coordinates of these ordered pairs. But the problem is to prove that it's isosceles. And it appears from the figure that the two sides that should be equal are side DF and side BC. So I need to complete the distance formula for side DF and side AB. So it's time to hit the distance formula. And remember, the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So let's start with the blue and the red side. So that's going to be the square root of 0 minus negative a squared plus 0 minus b squared, which is the square root of a squared plus negative b squared. And remember, when we square a negative, we get a positive, so we get the square root of a squared plus b squared. Now, I don't have any numbers. I don't have to go any farther. So now it's time to look at the black points together with the red points, and that's going to be the square root of 0 minus a squared plus 0 minus b squared. So that's the square root of a negative a squared plus a negative b squared. Remember, when we square a negative, it's a positive, so I get the square root of a squared plus b squared. I compare the two things. They are equal. I have proved that this triangle is isosceles. This concludes today's